Okay, this is part 2 of revising your floor plan to build a stronger, nicer, cheaper house. And emphasize cheaper, because that was, we're building this on Social Security. It's a huge house for no income to build it with. And that's why it's taken a couple of years to get as far as we have. This iteration is called round windows. That was the major change on this iteration. You see, this is a 4.5 foot window. The doors haven't been changed on this iteration. They become round top doors. Every door in the house, internal, external, they're all round top. But we did get rid of the glass block high windows for these ones. The glass block, if we just put grills in them, it probably would have been better intake air, or at least some heat from the house could get out. But we solved that later on. But we still have the glass block upstairs, and we still have a 5 foot stem wall holding up this roof slab. And these are those individual panels that stick out. I don't know what you'd call them, like paddles on a pump. I don't know. And we'll bring this guy over into view. You can rotate this stuff around. Oh, this has got a simplified ribs on the roof. You still got the 10 major spokes, but you got a lot less of the those little spidery spokes. This iteration has got the has to be in front of the camera. I'll just zoom in, that'll be easier yet. Okay, this has still got these individual walls. I thought it would be a place we could put a bench or some kind of chairs or awning, not awnings, but hammocks across. It was basically a small 3-sided room. It also takes all the weight of this top section, everything above this ceiling slab, and braces it against earthquake. So we had to have columns of some kind to hold this slab up, and they were just made that shape with about the same cross-sectional area, so they didn't cost any more. But they did give us outdoor living space right on the roof. I don't know I guess the part that's under the edge of the roof would be taxable. Don't know. If we never get an occupancy permit, it won't make any difference what the taxes are because they don't charge them. Anyway, it made it earthquake resistant, no change in the price on the concrete. And at this point we said, well, wait a minute. Those things are all sitting over top of tie beams that are above the ceiling. And it puts a weight, so what do you call it, load path. The load path of all this weight has got bearing all the way to the foundation underground. Because these have the inner ring of columns under them as well. And at this point we said, well, wait a minute. We make this roof thinner than what is drawn. It doesn't need to be that thick. We need a 12-inch roof. So not even sure why it was that thick when it was put on there. But in any event, we decided let's get away with that, and we'll bring this down to a 6-inch slab. And then we're gonna go to another drawing here in a second. I'll show you why we did some other stuff on this too. But we still have the glass block windows. The house is still semi-round, and we pretty much retained that part of it. Oh, something we will highly recommend. We were sitting at the point where we had these columns, coming up out of the ground, and they were concrete up to here, poured. It's one pour, We had a 8-foot form and then another form that wasn't quite 8 foot that did the rest of the height. But what I was going to say is when we had those columns, that was the end of our first trip over here. So we had them. We wanted to keep at least 2/3 of our crew working year round, and we figured we could, work 5 guys or something, and they're mostly family. And we kept all the skilled labor and 1 or 2 that weren't. And they filled all this dirt and compacted it over the shape of that floor plan. We got back. We had them leave out the dirt here between these vertical columns, and we formed our floor up so that it was bigger than the house. And actually, it's showing here about 15 inches wide. We wanted something we could set metal scaffolding or something on that was level. But when we actually built it, we brought this out another foot. So it's a nice sidewalk around there. It keeps water that splashes off the roof and this rain from throwing dirt up on the side of the house, so it stays clean. Never had a dirty house. At least not this one. Yeah, let's go to another one. We're getting close to what we turned in here. Okay, we're going to do a little pit stop here on the way, just because I opened this by mistake. And what we're looking at here is a setup for one of those walls. It's showing 192 inches, which is less than the length of the wall. But it doesn't show the 32-inch column. So it's 200. This wall is it's over 20 feet. And then there's about a 4-inch space on each end, which we put a cut to fit piece on. And if you pour the longest wall you have, because there's variances in construction, if you pour that longest wall, then that piece gets shorter. But you only get to use that about twice, because the exposed plywood edges, it falls all to pieces. And you have to have a decent looking finish, because you're not going to render this. The black things here, that's the bolts holding this to the one that would be over there if we had one. Here's one with 2 forms together. The round circles here, you'll see them here, 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 here. Those are the wall form spacers. You cut a piece of, I use 3/4, Texas Filipino uses half. And you cut that PVC, orange PVC or blue PVC, blue's cheaper, to the thickness you want the wall. And there's holes on form on the inside and a form on the outside, so you have a big flat washer, a piece of threaded rod with another on the side, or a bolt, a 10-inch bolt with a piece of pipe for a spacer and a washer and a nut. There's different kinds of things. But that is how the forms go together. This is the dimensions of our forms. It's important to have dimensions. Later on, you're going to put rebar, and you want the rebar to miss these 3 holes, these tightening holes. So you need to know where things go. So if you just draw one form, that's all you need. You can copy it over, but you basically just need one form. We had printed large format print of actually it's a couple strips taped together. It's got all the individual screw holes marked on it, where the facings are screwed onto these frames. And the deal there is, when you take that forming material and flip it over, because the screws are like, there's 2 screws here, two pieces of wood, 2 screws. They're diagonal. When you flip it over, when it's on the other side over here, you get to drill new places for your facing screws that are into wood that's not been drilled before. So it's like having a whole new form. We used the forms 26 times on the house and a few more times. And after pour 17, we had to start changing facings. And we have 7 of them that have new facings on we've never used. We had some downtime and just decided to do it. Okay. Red things are horizontal bars, run through the whole works. And you'll notice at the bottom down here, there's one between the other two. First, it's 3.34, 3 7/16, 3 3/8, I guess, closer, off the floor. And then, well, I'm not going to bother subtracting all this, about 5 inches and 5 inches. And then they go to a wider spacing. And the reason we have these different heights than all the standard thing is there's more stress on the edges of the concrete. It's like you tearing paper. You snatch the whole sheet at once, you won't budge it. But you get a little nick in the side, and you can tear it right in two. People tear phone books in two that way. Anyway, all the walls have this identical grid pattern. It was very simple to do. I don't know if anybody else does it the way I do it, but I call it notched form boards. Take 2x3 cocoa lumber, put a couple of them down, and you mark these dimensions on the cocoa lumber. So you come in and you drop your rebars into the notches, right? And they put them all at this exact spacing. And this is handy because later on, you know where this concrete was down here. You just poured it. And you'll know where all your rebar is going up the wall. We also have a, see there's a rebar here that's right down the center between the forms. This one. They're all spaced equally all the way across. And wherever your form ends, you'll have a rebar right near the end of the concrete if you do that. This is another notch board. So you got the vertical notch boards, bars laying in them. You cut these 12-footers and throw them up on there, and you have a notch board that's going on top. You just take it and rake it back and forth, and the bars pop up into the notches. And somebody puts a foot on one end, and you go up here and you rake the other one back and forth, and that gives you all the spacing. Now we painted we chalked a shape of the windows and cutouts and stuff on the slab of concrete we put these together on. See, if you pour your floor slab before you sealed the walls on top of them, you got a workspace big as a house. Why would you not do that? It's all sitting on grade. It's like a giant footer. You have to push that whole slab into the ground for this house to shift on wet ground or earthquakes or whatever. It's tied over the entire size of the house. It's easy to do. The site stays clean. You're going to spend that money on the same exact amount of concrete later, but you haven't got to wiggle through walls and stuff and carry it in buckets. You know, you can just put the mixer up on there. We move our mixer and dump right out of it all over the place. And we pre-stage our materials, like 2 sand, 3 rocks for each bag of cement. We have columns of it, like soldiers marching, just 5 bags across. And you know how many bags of cement you can mix by counting one row. That worked out well. Anyway, notch boards get you this. Say you're you wanted to drill a hole through this wall to run the air conditioning tube, and if you had to split aircon, you needed to drill a hole without running through a rebar, because then you have to fill that hole up and guess again. We know how far they are off the floor. We know there's one on the center of every place there's a seam in the forms, and you can see that unless you really go out of your way to hide them. So you know exactly what this rebar grid is. You doing electric outlets or something like that, they're going to be in the middle of one of those holes, So you can pretty much know where everything is. Oh, this up at the top up here, this is the beam. The walls are 7 inches thick and the beams are 14 inches thick and the beams are 24 inches high. That shows you that you have more bars at the end and then a constant space across here, and they're close together at the end. But this beam and this wall and that window surround, they're all poured the same morning. The entire section, 21 and a half feet in this case, is poured in a single morning, because we put the mixer right here beside it. And these forms have a bolt-on piece that sticks out 5 feet, and it's got a diagonal brace, and then an outside, and this goes up so there's a handle on the top, and they keep taking it off, but I keep putting it back. And the intermediate handle, I gave up on that. I couldn't keep them keeping that up there. They just, they had that look. They're such polite people, but they didn't want that on there. So I put the upper one. I figured at least they can grab the pole or something on the way by. But that kept our forms plumb. We didn't have to have all those bracing boards out at an angle, because we had that flat floor. When we put the scaffold boards up there, they were 30 inches below where we're going to pour. Then they were on the floor, which is level inside. And the level floor plumbs the wall forms. This form on the outside, we're not pouring from the outside. They only have to pour it in from one side. So the scaffold goes on the concrete floor, and this out here didn't have any. And after we poured 2 walls, we decided we wanted it, and we made some triangle pieces we could put a top on. And they bolted a long bolt here, and this end just went down and sit on the ground. And then the diagonal one, it would be coming out towards you. It was up there in another piece. But that let us something, because we had this sidewalk thing poured around the house. That gave us something to set this one leg on. I think there was a little piece of wood goes down here too, because that piece of concrete is 2 feet. And I think we made that bottom piece about 18 inches. I'm not sure why. I think we had a guy make it, and he says, "Is this all right?" I says, "Yeah, make 5 more." Anyhow, they let you know where your rebar is inside your wall if you're going to drill a hole later on. Oh, the window frames, my wife made these. Story on that too. These seams here, they like these green ones go from here to here for a piece. The blue one laps over it. It goes halfway in between. There's 7 layers of 2-inch pressure-treated lumber. It's got the entire jamb for the window. And the reason we have round windows, because I'd gone to the hardware store, I don't know how many times, till I was tired of it. And I kept asking for a stock size window catalog, rough opening sizes. Couldn't get it from them, couldn't get it from building inspectors, couldn't get it from anybody. They say, make the hole, we'll make the window to fit. So I got up there one day and Mimi, I said, look, I just need to know how big the hole. It's going to be even multiples of concrete blocks, isn't it? It's like 6 blocks wide, 4 blocks high. What size do you make the windows? It's the first time I've ever heard her get loud. She said, you make the hole and we will make them do fit. And everybody turns around and looks and says, okay, I'll just make the hole and you make them fit. So I go back to Aurora and says, I got the size we can make the window. She says, what? I says, we make the hole and they'll make windows to fit. She says, that's custom windows. Says, no, that's a standard window here. That's the way they do it. And she says, well, the house is round. I was worried about if our windows were out of parallel or something, or taller on one side than the other in the opening. Well, how were we going to take care of it? She says, well, couldn't you have round windows? The house is round. I said, I don't see why not, because they'll make it to fit. And she says, okay, let's do that. I said, well, it's going to kind of look kind of funky with the square doors and a round wall. And she said, well, I don't know about a round door. I said, well, how about a round top door? Straight size round top. She says, yeah, that'd be fine. So we just drew it up and put the round windows in the bottom. And later on, when we decided that we had to have a stairway dig up to the top for other things, then we just raised that 5-foot roof up to 8 feet, and we would have lanais all over the place up there. And we put round windows in those, so it looks balanced. There's a I don't know, an art to architecture, I guess. Anyway, this was all opened by mistake. Oh. This is counting up stirrups we need for something. Oh, these are the length you cut them. You cut the individual pieces. You shear them that long, and then we made a special rebar. Well, this is total bars and what you cut out of the bar. I would give my wife this list, and she just haven't cut them. I never had to look at it. You know, I leave in the morning on the motorcycle. I get to the job or not. I'm allowed to go any place. I worked at a steel mill one time, and me and Maravich, we'd be going to work and see each other, and around lunchtime we'd be in Florida, New Orleans. I said, "Well, they could fire us." He says, "I don't care." I says, "I don't either." So that's what we would do. Okay, we're gonna pause this and get the drawing we were trying to get. Okay, here we are back again. This is a major change. Remember, we had these little short walls going out here with glass block walls in between, and that big heavy roof. And I was looking at these spaces in here, and see, this is like a spline shaft, really strong. If an earthquake is shaking or trying to torque the building, and the idea was here. If I was going to put a beam across to set this concrete slab on, basically, if I had one going over here to the next one, you would have to end at the middle of the beam. Does that make any sense? It would end over here, and that's all that would be sitting on the wall is that little bit. Of course, you'd have rebar going from one to the next. They'd be hanging out, and then you just bend them in the right direction and put the form back up. Or you could pour it one continuous beam all the way around there, but that would make you buy forming materials for the whole ring of beams. And we did this with absolute minimum amount of plywood. Anyway, I got to thinking. I says, you know, I'd rather have this beam go across the whole tie beam underneath. And that tie beam is it's not only 24 inches tall. It's got a 10-foot wall or 8-foot wall underneath of it, which is solid concrete going down to a tie beam on the underneath of it in the ground. That's direct load path. You can't make it more direct than that. It goes from a beam into a beam, but the beam can't flex because it's got a poured concrete wall right down to the floor slab, and it's continuous, and then the beam in the ground is continuous. So that's just absolutely load path. I says, okay. And first I drew it up with this right beside it here, you know, and tried with one end swung around half a beam and the other one swung the other way half a beam. And thought, well, you could see that in the room. I don't like that. So I thought I would move them in enough that it was not over it at all. Because it might be a door down there or something. I didn't want to bother looking. And now you notice that our posts, this blue line here might highlight. No, it's not going to highlight. It's a different shape than the ones down below. The 20 down below, you pour the outer ones, and when you put the forms up for the inner one, you just rotate them 180 degrees, and the same form does the inner one. It was designed to do that. The downstairs and this, they both have notches set into the side of the column. The reason for that is we were using hollow blocks when these columns were designed, and that was so that the blocks could register into the this 7-inch wide space. And again, just to keep it from sliding back and forth in an earthquake. And there was a bunch of rebar stuck in into this. Well, we did that anyway when we poured the beams. But this was to register the wall into the columns, just to lock it together. It's a big puzzle. It was not that hard to do, really wasn't. Okay. Oh. Over here. This is the stairwell. Remember this used to have a wall here, back and forth. But when we got that 4 feet plus the thickness of the wall back, like 4'7", we could come up this, and you had head clearance by the time you're here. And by the time you got around here where you're getting close to the wall, you had 18 inches over your head and, you know, full 2 feet over here. So climb them that way. What we're looking at, these pink beams are not on this level that the staircase. The staircase goes from this concrete slab up to the top of these. There's a floor on top of these. So the pink is you got to watch the load path, but it's not the that part of it. Now this is the door that goes out onto this mezzanine deck out here, and it's got a set of staircase that goes up around to get on top of this roof. So when we poured that slab up there, we left a shape. What did it go like this, and it goes around curves, and it got a curved end on it too. Got to have a curved end. This ring around here is a concrete stem wall. So like your handrail and all the stuff underneath of it, it's just a big U-shaped trough. We could line it with stainless steel, use it for a slide to go down if we wanted to. But we still have the pink beams for the same reason. And looking at it, see, I have a catwalk here. This is another thing. We just took the center out of this floor. It's a 24-foot span across here, and this is 2.5 feet wide. This is not living space up here. This is closets. And this is a catwalk around the inside. We saved some concrete up here because we put doors in every one of these panels all the way around. So the amount of concrete that's left is mostly the top tie beam. There's one of these tie beams, same width over here. But I got looking at it and said, well, wait a minute. If I take these and slide them out, you know, about to here, that gives me something that's starting to look like a room in there. And because they're slid out, now my little lanai area has gained 3 feet. It's almost an outdoor room. So I said, how much more does it cost? And you're basically adding 14 inches of wall length per room. So times 10, it's 140 inches, 11.5 feet of concrete. And I said, well, it's a much more functional building. And so we're going to do that. It's going to run the price up a little bit, but it's, when you have 600 feet of walls, what's 11 more, you know? This staircase is a 30-inch high concrete wall with the treads coming off of it. This one here has got a single beam around in here with the treads balanced on them. And instead of having handrail, there's stainless steel rods that goes up to the ceiling, through the ceiling onto the roof. That's called monostringer. It's about the same size as this one, but it's monostringer instead of string on both sides. And let's have somebody come over here for a visit. Okay, this is well, this is that mezzanine roof, and this is what those walls would have looked like if I didn't move these out. And see, this is an out, the next one's an in, this one being out. But it's out from the center point. So what I did was I moved this one out twice. And that's how we got that bigger room. And we added some more at this iteration, we've put windows in the wall, window holes, round holes, 37-inch diameter. They're in scale with the windows down below for the length and height of the walls, because these walls are 8 foot, the other ones are 10 feet, 1 5/32, and these are 8 foot even. There's another trick on this. There's a lower tie beam, column on each end. Oh, the time is getting up again. There's a tie beam on the top, column on the right. Basically, we put longer pipes in a space that forms 14 inches apart. And then we had a 2x4 perimeter piece that goes in here with other phenolic board on it. And that made the recesses in the wall so that the wall here is no thicker than it is anywhere else in the building. So we poured 2 tie beams, 2 columns, a wall, and a window jamb in about 3 hours apiece. And we only made 1 set of forms. All the red ones were done before we left for vacation in the States. And we had the guys do this. I thought it looked simple. Turned out it must not have been. There's no 2 of them the same. And there's it would be on the inside of the room. It would be right here. We have individual circuit breaker boxes for this area and the room underneath of it. Sub panels. Under the sub panels, there's just a void in the concrete we boxed off. We boxed off a tall rectangular section. The breaker box sits in the top, and on the bottom we have a couple flat bars with terminal strips on them, because you can't get the wires bent around and into the breakers in the panels they sell here. It's only about 3/4 of an inch between the side of the breaker and the side of the box. Try to see if you've got the wire into the screw before you tighten it. Just can't be done. So what I was doing was snapping the breakers out, putting the wires up and put them back in. It was a nightmare. So I just bought the terminal strips, and we bring them all to the terminal strips, and all the ones that are going to go on a breaker, they get jumped on one side onto the terminal strip, and then you have a single wire goes up to the breaker. So it's easy to put 1 wire under a breaker, but it's hard to put 3. So, and everything is home run. There's no boxes anywhere in the concrete. Only the switch or receptacle or whatever it is where it comes out to hook something to it. And the other end of that pipe comes in here. There's no junction boxes with covers on them and all that kind of stuff. There's no. This is looking down through the to the living room down below. My way of thinking, if they get touchy on floor area, this is not floor area. It's not a floor. So the area I'll have to pay would be on this right here. I don't think there's anything else we have to cover here. So y'all have a nice day. Say a prayer for the sick people. Bye.